Okay, guys. So last week you learned a couple concepts of how to do molar conversions. So I know you've had a week in between all that. Now, last week's material goes on this fourth 9 weeks. So I want everybody to understand that most of the stuff that you did last week is going to go on the current 9 weeks. So all that dimension analysis stuff and mole conversions and things like that, I'm trying to keep consistent within the same chapter. So therefore, all that information will stay with the fourth 9 weeks. I wanted to kind of review with you material that you guys did the week before spring break. I don't want to jump right into something and not have you guys understand what you did the week prior to that. So what I decided to do is I'm going to go over this small little worksheet. It's not really a worksheet. It's just some notes. So you have me giving you examples, and then you're going to work on today an assignment that's just a review of two of the concepts that you learned last week. So the first concept, not the first, but one of the concepts you learned last week was how to calculate the molar mass of a formula, okay? So in this example here, they're giving you lead to iodide, all right? So the formula for lead 2 is PbI2. So that's going to be my formula. Now, the formula for calcium nitrate will be CaNO3 with a 2 outside the parentheses. So we're going to calculate the molar mass for each one of these compounds, okay, these ionic compounds. So first of all, you're going to want to write how many you have each element. So I like to stack things. So for the first one, I have 1 calcium. Now, when you have parentheses here, you have to distribute that number to each individual element within the parentheses. So I have 2 N's and I have 6 O's. Okay. So now I'm going to go to my periodic table and I'm going to look for calcium, and I'm going to see that calcium has an atomic mass of 40.08, and I'm going to times that by 1, and it's going to give me 40.08. Now I'm going to go find nitrogen. Nitrogen has an atomic mass of 14.01, and I'm going to times that by 2, okay, because I have 2 of them. So that's going to give me a mass of 28.02. And then oxygen has a mass of 16, and I have 6 of them. So I'm going to times that by 6, and that's going to give me 96. So now I'm going to add all of these together, okay? So I have 0.10 here, then I have 14, 5, 7. So that should be 164.10. Now I'm going to go ahead and check my mental math here. So we had 40.08 plus 28.02 plus 96. And that's going to give you 164.10. Okay. And that's your molar mass for calcium nitrate. Very easy. You just look on the periodic table and add up how many, or multiply by how many you have of each one, and then add them all together. So let's do the same thing with the lead iodide. So we have 1 Pb and 2 Is. Okay. The atomic mass for Pb is 207.20. Oops, times 1 is going to be 207.20. And then iodine is 126.9 times 2. And that's going to give me 253.80. Okay, so now I'm going to add that to the 207.2, and it's going to give me 461.00, okay, for my molar mass. And molar mass is always measured in grams per mole for your units. Okay, so that's the unit that we use for molar mass. Very simple concept. You just look on the periodic table, find your molar mass or your atomic mass, multiply by the number that you have, and then add all of the elements within that together. Okay. Now, the other concept that we learned was how to convert from either particles to moles or moles to particles. Okay. So in our example of that, so for this one right here, how many moles of ammonia, and the formula for ammonia is NH3. are in 1.2 times 10 to the 25th molecules of ammonia. So now remember, in a problem like this, you're always going to start your problem out with what you were given. Okay, so in this problem, we were given 1.20 times 10 to the 25th molecules of NH3. Okay, and that's all over 1. All right, you don't have to put it over 1. I just like to put it over 1 because I'm dealing with ratios. Now, if I go back to my mole roadmap, remember the roadmap I shared with you, okay? If I'm going from molecules and I'm going up the road to moles, okay, my ratio is going to be 1 mole over 6.02 times 10 to the 23rd molecules, right? That's Avogadro's number. Remember, we talked about that. So now I'm going to take this and multiply it by this ratio, which is 1 over 6.02 times 10 to the 23rd. Now remember, if you're using your calculator, okay, above the 7, there's a comma right here, which is, so above number 7, there's a comma, and it has an EE button, okay? This EE button will actually bring it to a power of 10 for you. So let me tell you how to do it. So I type in 1.20, I hit second comma, and it gives me this EE. Okay, do y'all see that? That EE. Now I'm going to put in my exponent. I'm not going to hit times, and I'm going to put in 25. So it's going to look like this. Okay, 1.20 EE to the 25th. That's bringing it to a power of 10 for me. Then I'm going to multiply that by a fraction, 1 over 6.02 second EE 23. So now it's going to look like this. Okay, so you're going to multiply by 1 over 6.02 second EE to the 23rd. Notice how there's no multiplication in there, okay? Then when I hit enter, I'm going to get a number of 19.93, okay? So my answer for this is going to be 19.93 moles of NH3, okay? All right. So as we're moving along, that's how you type it into your calculator, okay? Now, let's move on to the next one. So in this next one, it says you have 2.5 moles of aluminum for an experiment. How many atoms of aluminum is this? Okay, so we're looking for an individual number of atoms for aluminum. So once again, aluminum, my formula is Al. So we're going to start off with what we were given, 2.5 moles of Al over 1, okay? Now, if you look at your roadmap, now we're going from moles to particles. So we're going down the road. So if we're going down the road, the fraction we use is 6.02 times 10 to the 23rd atoms over 1 mole. Okay, so because we're going from moles to particles now, the conversion factor flips. So you flip the ratio because we're going down the road instead of up the road. Okay, so now we're going to take 2.5 times 6.02 second EE 23rd, and we should get an answer of 1.51 times 10 to the 24th atoms of aluminum. Okay, so after this video, I want you guys working on that worksheet that I'm going to give you, and it's just going to focus on these two concepts. Okay, so work that out. If you have questions, please ask, and I will do my best to get back to you as soon as possible. Okay, so have a great day, and I hope this helps you in understanding how to do these two conversions for the mole. Okay.